and this is my project presentation on AI product adoption, the course final presentation. So this is a peer graded assignment, and this certification program is from Duke University under Coursera. My name is Sean Rai, and I'm going to present you the solution for my AI product adoption. Now, the grading criteria, as we understand, this will be a peer graded one where it will be based on task analysis. Did I clearly describe the problem I've selected? User experience design. Did I explain how the user will interact with my proposed solution? Privacy consideration. Did I explain any privacy related concerns stemming out from this data that I'm collecting? And the ethical consideration. Did I identify the main potential sources of bias that I anticipate and how I describe how the product will meet the goals of ethical AI? Talking about that, just a prelude to my project presentation. In today's world, energy management is more important than ever. Globally, every industry, and in fact, as I'm talking about telecom industry, so they are faced with a huge challenge of energy management. The telecom sites, the RAN sites, consume a lot of energy throughout the day, and there is a continuous pressure globally and from sustainability angle as well to reduce this energy footprint or the CO2 emission. So in today's world, the network related OPEX, around 20 to 30% of that is for the energy consumption itself, and this trend is going to go up and more because we are talking about 4G, we are talking about 5G and other internet of things. So this energy consumption is definitely going to go up, and as you can see some metrics around what different telecom giants are doing globally in order to reduce their carbon footprint. So having said that, my project is around reducing the telco RAN energy consumption during low traffic hours using ML. So ideally, these telco RAN sites they are switched on 24 cross 7. So during low traffic hours or when there is no traffic at all, we can always switch it off, right? It only makes sense. For example, if you're not in the room, you will switch off the light. That makes only sense. So the task analysis, the problem, telcos consume unnecessary energy by keeping all RAN cells active during low period and low traffic. The task is to predict low traffic hours and deactivate RAN cells accordingly without affecting the network KPIs. And the basic task flow is gather this traffic and the network KPI data, continuous, then predict low traffic period. Now this would require AI ML engine to act on the historic data, then lock unlock cells accordingly. Now for this you will be requiring an actuation engine. Now the insights is automating the predictions simplifies manual monitoring, and clear dashboard visualization improves user interaction and trust. So just understand that an external solution would be going into the network and perform this lock unlock continuously. So it only makes sense, or it can be trusted only when there is a continuous visualization as what is happening. If everything is happening inside closed doors, then the network manager would not be allowing for any software to take action on this. Now, talking about the user experience, so the network operations engine, the users would be the network operation engineers. The interaction would be access dashboard with traffic predictions and approve and override automated locking actions. So basically, there will be this policy manager or an actuation override button in order to activate these cells remotely. Then AI UX consideration for the user interface experience consideration, the user inputs would be traffic and the KPI data. Transparency would be to show confidence score and explanation for each prediction. Uncertainty would be highlight predictions with confidence intervals, flag low certainty predictions for manual review. And feedback loops, engineers can level false positive negatives for retraining. So that's how the ML model will continuously improve itself, and it can gain more trust and momentum in its operations. Now, the privacy considerations, the data used would be the historic traffic data, the KPI data from the ENM or the NMS, which is my network inventory, network data storage place. Concerns is the exposure of sensitive operational data, which is highly unlikely as we are only talking about the traffic data and the KPI data, which are required to model this ML algorithm. Now, unauthorized access to network configuration. Now, this is very sensitive because all this would be software driven, and we do not want anyone gaining access to the network traffic and uh, going ahead with some wrong malign intentions. Right? Applicable laws, GDPR laws, if in Europe, general data protection policies. So this would apply. Obligations would be secure data storage and access control, ensure anonymization and compliance with data minimization principles. Right? Now, ethical considerations are the historical anomalies. Example, when COVID took place, the entire the way network traffic behaves changed a lot. So instead of office hours, which is let's say normally from morning 9 to evening 5, changed from throughout the day. You would have high traffic, then uneven data sampling across geographies or time. So urban area would have more traffic, rural areas would have less traffic. So those kind of anomalies are there. Then fair, in order for fairness, ensure rural and urban areas are tested equally for energy saving actions. Accountability, human override, and logging of decisions for adults. So this is very much required to have that human override. And in terms of transparency, clear explanation and traceability of the model decisions, what the model is doing, what actions it is taking, needs to be clearly documented and continuously shown in the dashboard. Now, the model components, I was trying to design a simple model component. So the data, with the sales side, the PM data, the KPI data would be coming from the ENMs into this ML engine where we would where one would crunch the data in order to predict when and how to log the cells, and there would be the actuation engines, which would be automation engine, let's say, which will act on those outcomes predictions in order to um, perform the locking and unlocking, and the outcome would be reflected in a dashboard. And in case there is a failure in, let's say, locking or unlocking the cell, it will take automated actions, or it will immediately inform the manual counterpart. So this is just a sample of how, let's say, the traffic data looks like throughout the day, and the engine would compartmentalize this traffic pattern and would accordingly use a threshold in order to lock unlock. For example, during low traffic period, which is night 12 to morning 6 o'clock, it would be using an aggressive threshold to lock. During daytime, a moderate, and during afternoon when the traffic is very high, so that's time it will be using a conservative threshold in order to lock unlock, if at all. Now, a typical output would look like something of this sort, um, and it would be real time. So we'd be getting total locking hours in a day, what it means in terms of energy savings, in terms of dollar value savings, and in terms of CO2 reduction. So essentially, it's about the locking hours and what energy it is able to save. Now, the benefits, as we understand, CO2 reduction and also operations cost savings. And the next step for us is to integrate human feedback loop, monitor real time performance, and train regularly. That is all. Thank you so much and have a good day.